let's talk about IP addressing. Which test are y'all on? Or are we supposed to be
We
on?
just took, Monday, the chapter 7 test was due, and we're now on chapter
8. Okay.
7.
So we're really going to talk in 7. So we're off slightly on that. I'll go ahead and reopen 7. Actually, let y'all take 2 times. I'll reopen it. And if you want to retake the test, you can. Just bear in mind the rule on it that it's going to go with the last score. Is what it's going to keep. So if you retake it, it's going to keep that second score, not the highest score. Everybody follow on that? But I'll let you have that since we've gotten mixed up here between all the different things going on. And we'll do just a sort of overview on this. I would rather spend a whole lot more time on it, but we just don't have the time in class this semester to do it. Between the conference for me the other week, getting sick last week, and then we got break next week, which I actually had designed in there. But I didn't have really planned on being out sick for a week. That because as far as the other, we would have survived around that. We had time there, but we lost 2 class periods on that. So let's look at addressing. I do have that you found that there's a lot of other materials I put out there for you anyway in Blackboard, so you've got other materials that you had to study from also. So it wasn't a case of all you had was the book anyway, that you had some videos from me, some handouts from me, etc. talking about it. We have been doing IP version 4, and that's still currently used. And we're shifting to IP version 6. Okay? And that's been an ongoing process for almost 20 years. Okay? So the IP version 4 dates back to about 1980. I don't have exact dates on when it was developed, but it was developed right around 1980. They went and created a system for addressing machines on the internet, or on networks actually, and on the internet at that time, and thought that they had developed a system that would be highly useful way into the future. They thought they designed it with the future, and they designed it with their perception of the future in mind at that point. But keep in mind that was 1980, the appearance of the first desktops just appearing at that point. Not much use of them yet at that point, that it was mainly some specialized purposes or hobbyists that were having them. Not many people owning one, because until 81 with IBM coming out with it, they were out there, but they were very limited in the amounts, and then everybody was jumping into it, but you didn't have a whole lot of people using a desktop computer or having one. No concept at that point of what in the world we would end up with of all the different network devices that we're using now, or even that just less than 20 years after that development point that we hit a problem. So developed there in 1980, and then it hit drastic problems about 1998 or so. Don't remember the exact year, but actually should be about 1996. We knew the problem was hitting and that we were going to be into a drastic problem in 97 or so, 97, 98, but it was all predicted out by spring of '96. And that the internet was headed to come crashing down, collapsing under its own weight. IP version 5 had begun being developed somewhere back there around 90 or somewhere back in that time range or a little before, but really to adding capabilities to the IP protocol, not really dealing with addressing. With the World Wide Web and the explosion of the internet, that they threw out what they had started on an IP version 5 and went to creating IP version 6. With the main emphasis on it of increasing addressing space, but also increasing reliability, etc., on using it as a protocol out there to getting a better version of it. And went drastically working on it there in the late 90s to get IP version 6 protocol developed and approved through. So you had the situation occurring there in the late 90s of that there was, with the way that IP version 4 originally worked, that we ran out of addresses. It was not efficiently designed out there. They thought they had done a good job of designing something, but it was not a very well efficient one, and it had no concept of all of these individuals having computers and that there'd be this ton of little tiny networks. There were some ways figured around that at that point. NAT came about at that point, and with the use of NAT, Network Address Translation, we were able to get by, and that there was then addresses available and things survived. Although IP version 6 did start being used some, okay? So IP version 6 is not something brand new today like you may get the impression of sometimes when you read about IP version 6 out there. It's been here for 20 years. It's just conversion to it has been slow to occur. Because after we got over that hump there and that it was solved, that then things continued to work on with IP version 6 of slowly converting on it, but nothing drastic anymore, and that there was plenty of addresses available again using IP version 4 with workarounds that we had developed, particularly through NAT. A year and a half ago or so, or about a year ago, either a year or two ago, somewhere in the last 2 years, and I can't remember if it was a year or 2 years ago. And it may well be a year, but I'm not exactly sure to remember in my head when it occurred. We've actually run out of IP version 4 addresses again. So we're back to the 90s again. So y'all can party like it's 1999 again. Okay? We're back to the same place. We've sort of run out of addresses, but we haven't completely run out of addresses. IANA no longer has addresses available to issue to the ISPs, to issue out to users. Okay, that they have run out of the massive big block of addresses to give them away any longer. However, most of your ISPs and your country organizations, etc., had more addresses than they were using already, so they still got addresses there. There's also some addresses become available at different times as people give up addresses, and there's some addresses available again. So for the time being, even though technically we're out of addresses, there's still addresses out there, and that organizations continue to do. Problem is, any new organization that wants addresses to start issuing out, they've got to go to an existing organization and get them to share addresses with them to work with. Okay? But somewhere in the near future, it is going to come on down to a real crunch time. That we're into that, but we haven't gone to full crunchness that yet. Where in the 90s, we had hit that point. There were, literally, it got to the point where there wasn't addresses to continue to issue as they're desperately were trying to figure out a way around it, and that's when NAT came about. And with the adoption of NAT, that we worked around it. What NAT does is you've got public addresses and private addresses. Okay? Private addresses are for use on private little networks, but not out onto the real internet. Okay? And there was private addresses created with the original IP version 4. The idea when they did it back then in 1980 was that if you weren't connected to the internet, you would use these private addresses. And if you were connected to the internet, you would get issued an address by one of the address authorities, and you would use those addresses. So they reserved out a number of addresses out there for private use. Now, in actuality, the private ones didn't really get used a whole lot, because if yours was a private network that was not connected to anything else, it really didn't make any difference what addresses you used, because you weren't making contact with anybody else anyway. So people just used whatever. Sometimes they used the private ones, sometimes they picked a public one and used. And as long as they didn't connect themselves to the internet, there was no problem. Okay, if they did, then there was a problem, and then that had to be fixed. With NAT, up till when we used NAT, every device that was connected to the internet out there had a public address. Okay? Its own specific separate address that was very specific on the internet. With NAT, and so that meant everything that we connected out there had to have that public address. With NAT instead, what we have come up with is that you have a NAT server that will convert addresses when you're connecting to the internet. So if this is your little network, you've got a NAT server here that also happens to be sitting there, sitting as your modem, etc. to it, that connects you out there through the big platform, okay, to the whole internet. What happens with NAT is prior, everything in here had addresses that everybody out there recognized, which meant we could make contact with whatever machine we wanted, wherever. So when I set up Swinsboro Tech in 1990 onto the internet, we could sit on any of the machines that I had connected to the internet, and we could correspond to any other machine in the world to their specific address. And they could correspond specifically to us, and we all saw the traffic of everything traveling across the internet. Does everybody follow on that? So it was a wide open, and when they talk about it being the Wild West, it was to a degree on that. It was anything and everything went. I could sit on my machine at home, Savannah could put in the IP address for my machine at home and go straight into it with no problem at that time, and see exactly what I was doing on my machine. And I could do vice versa to her. May or may not make her happy. Okay? And we could do that with anything and everywhere. We could hit the machine sitting in China, the machine sitting wherever. They were all open. Okay? With NAT, we now use private addresses here, and everything out here is supposed to be public. Okay? Not really, because all the networks sitting out there are working just like this one. Right here, we actually have a public address and a private. Okay? Now, what happens is, you go to do something on the machine here. It has a private address on it of what you go to send. That address will not work out here because it's an address could be used all over the place by different people and the internet doesn't recognize it. Okay? But what happens is that the NAT server right here, when you go to send, it hits to here. The device sitting here looks at it and says, didn't belong inside the network here to anybody, so I've got to do something with it because that's the default gateway sitting there out of our network. So it says, I've got to convert it from the private address that's got on it now, put a public address on it, and ship it on out. Now, we may have 40 machines in here. We'll just use as an example. We'll have one public address for our whole network. We've got 40 private addresses sitting in here, and what's seen out on the internet is one public address. This converts that packet going out from that private address and sticks a public address on it. Usually there's only one of them. You could have a couple of them in your organization, depending on how big your organization is. But you're only going to have a couple of them, and they're all going to share that address going on out here. Goes to where it's supposed to be. Savannah wanted a copy to see what was happening on CNN right now. So it ships on out to CNN. CNN sees it came from here, not from Savannah. If I follow on that, CNN sends back the web page to here because that's the address it's got. It really doesn't know anything about all of these. When this gets it, it looks at it and says, that's not really for me. That's actually going to Savannah, so I will change the address from my public address on it and put her private address back on it and ship it on into the network. And it goes to her. It sits there and keeps track of every one of them, is sending out which one it belongs back to and maintains a table of that information so that each one of you could be shipping at any point. We could all do it at the same point. Changes everything we send out to the same address going out there, but when it comes back, it knows which one of us does it belong to, so we don't get all kinds of mixed up stuff. So she gets her CNN page, and I get my page about my AT&T email. And that she doesn't get my email page and vice versa out of it. It sends the correct one to the correct one. All happens in the background, so none of us know it's really happening there. Does everybody follow on that? And that's really what's happening right here now. Okay? You go send the page, it looks like you shipped it off to wherever the request. It comes straight back to you, but it actually did some address converting along the way. Same thing to you when you're at home. Your machine's doing the same thing there. By doing that, now we've got one public address for a network instead of needing 40 or 200 or 1,000 or whatever addresses there. And y'all can see where we've now expanded how many addresses we've got available, and we don't need all of this ton of addresses before. But if you go back to 1990, when I set up Swainsboro Tech onto the internet, and all the other tech schools set up at the same time across the state, they gave us all a Class C address, which I'll explain in just a second, which gave us each school 254 addresses to use. Now at that point in 1990, and this is give or take a year or so, each of us sitting there were going, what would we ever use 254 addresses within a school for? Because the only thing we saw for internet connectivity that we needed from the school was we were installing Banner at that point in all the schools, and we wanted, the central office wanted to be able to check in on student records on the schools, and they also wanted to check accounting records, a couple of people in the state office. And that involved one or two people at each school as far as connectivity across the internet. The rest of it was just within the school. We saw that those of us in there setting it up as the head of IT for the different schools, that we wanted an IP address so we could go out on the internet and do some stuff, but there were no World Wide Web pages. It purely was you had to put an IP address number in, and you could go look in libraries and other stuff and pull up pure text documents and that type of stuff and search for some stuff. But you didn't have all of these graphical, colorful pages, advertising, all kinds of stuff. Does everybody follow on that? And I saw my students in my one lab in the school. It would be nice to have all 20 machines in that lab connected to the internet so that my computer students could also get on the internet and find some stuff, and we could do some email with some other people across the country and stuff. And beyond that, we're going, who else is going to need the internet? Okay? So our question was, what are we ever going to use 254 addresses that they just issued to us for? Now, stop and think about it. As small as this campus is, we probably have well over 254 machines connected to the internet today here on this campus. Okay? And we were talking about 254 addresses per technical college then. I'm going, what for? Okay? Beyond that, we got wireless floating around here in school, right? And then y'all can connect your phone to the wireless. And I forgot to put it on vibrate. And then I'll reach down there and thump that. If my phone will let me put it on vibrate. So, lots more connections for us, because besides all of these machines and all of these rooms that we're all connected to, and machines sitting in the library, and we thought back then maybe a couple of machines in the library would be nice connected to the internet. But think about it, we're only talking 30 or 40 machines at most if we thought big on a college campus, okay, going to the internet. Now, y'all got all of these PCs. Every one of you, including me, obviously, probably have a phone on us that's connecting to the wireless in the school here. Guess what? We get an IP address for each one of those devices issued by the school. And there's other things sitting around here too. If y'all look across the front of the building, there's 3 cameras sitting out there in front, pointing out across the parking lot, recording what goes on out there. There's a couple of cameras in the hall. They're all running across the internet, so each one of them's got to have an IP address, etc. Okay? So we got tons of stuff, but this got us around for 20 years. Okay? It gave us because of the faith. Now, let's look at how the IP addresses actually work back there to version 4 and then version 6. Now, version 4, because of the way it was set up, it had huge inefficiencies to it. Version 6 gives us, I'm remembering the number correctly, I think I am, but if one of y'all looking at it there in the book, you can tell me I'm wrong on exactly what it's called, is that we had millions of addresses in version 4. In version 6, we've got 30 quadrillion. I think it is. Is it quadrillions? Anybody remember the number on that? Which should be 30 zeros after the number. Addresses available to us on IP version 6. Okay? With the way they've designed it. IP version 4 had the 4-dotted numbers for an address. Each of these ranged from 0 to 255. These were each octets. because you're looking at 1 byte each, and that's the biggest number you can get into 1 byte is 255. Okay? The setup that they split it into, they lost a lot of addresses. With IP version 6, you've got 32 hex characters, which are going to split into groups of 4 going across there, okay? Of 4 characters at a time, and they're hex, so they can be numbers and they can be letters A through F, and they're separated by colons. And so on for 8 of them, so there'll be 8 groups. 1, 2, 3, 4. So that you've got that. These are hextets. Although if any of you are taking the test out course of PC repair, they wanted to call them some other word, that quartets, that they called them, and I've never seen anything else called quartets before. I don't know where they got that one from. Hextets is what you normally see it as. These as octets. Okay? And this goes back to the fact it was really off of optical, although you're really not using optical to it. They were in binary, but it was a byte at a time, and that's where it came from, octets. This, you're working in hex, so they call them hextets to be similar to this. Okay? Now, with IP version 4, there were classes A, B, C, D, and E addresses. Okay? Classes A, B, and C is what you really regularly use. Although we really don't do them by class anymore, and we've quit using them purely on class, and now we actually split them smaller. Though in 1990, this is what they issued to you as a Class C address. Okay? Class D is multicast, and that was a group of addresses reserved for sending things across to multiple addresses. When you stream movies, you're actually multicasting. It's not sending out separate streams to everybody. It sends out one stream that goes to multiple addresses. It does not use as much bandwidth on our network that way. Playing games quite often will hit into multicasting too. Okay? Unicasting is what you're normally doing between machines. It's one-to-one signals going across. Class E is experimental / government / research. They reserved a group of addresses out there that were not to be used by the public and for general purposes, but to be used for developing additional things about the internet, and also that the government is the one that developed the internet, the U.S. government. And so they reserved themselves an area of addresses purely for U.S. government's use, and it's partly military usage because the military was the developer of it, and part of it for intelligence agencies, etc., is my understanding. I have never seen one of these addresses in use. I have been told they're used out there. I've also been told that if I was to see an address, one of those addresses from something coming to me, that I couldn't tell you all about it anyway because I'd have to kill you after I told you about it. So, as far as I know, I have never seen one, okay? And so, if by chance I had, I'd still not tell you about it, so I wouldn't have to kill y'all. Okay? Y'all tend to prefer that one. Because y'all may be sitting there thinking, well, it'd be neat to know about it, but no, I don't think I want to be killed because I found out about it. Okay? But that's what Class E is. And in a lot of books, you'll not even see Class E mentioned. But Class E actually exists. Because it's that special purpose, A lot of times people won't even mention about it even exists. Class A, and there's public and private Class A, B, and C addresses. Class A was any address that started with 1 through 126 or 127. 127 is a special case, and again, it was poorly designed. Class B is addresses that start with 128 through 191. Okay? Class C was 192 to 223. Class D actually is 223 to 239. And this would be 240 to 255. But don't worry about those. So there, if you do the first part of it, now that's working off of binaries where those numbers came from. They didn't just draw those numbers out of the sky. They went and used that. For this one, it was the first byte, and the first bit was 0, and then it used the other 7 bits. But it always started with 0 on it. Okay? This one started with 1, 0, and then used the other 6 for variable numbers. This one was 1, 1, 0, and then used the other 5 numbers. So they actually used the system off of it. It took a long time before I learned that one. I kept going, where did they get these numbers from? And when I went to do my CIST, and they'd asked you on this, they hadn't explained it to me at all, where they got numbers from, and trying to remember those numbers was always hard. And then I'd go, what were they smoking that night when they came up with these numbers? But you look at those numbers and you're going, there's no pattern to those numbers. Why isn't there a pattern? There actually is. Now, Class A can be any of those. The private ones for Class A is anything that starts with 10. Class B is anything that starts with 172.16 through 172.31. That's the confusing one. Biggest thing to remember on that about Class B is remember 172. I've really never had any questions on a certification test that I had to know this down specifically. As long as I knew it was 172 was what was Class B, I could answer the question. It took care of itself for me from there, that I could throw out the other answers. Okay? And Class C is 192.168. Now, think about it. Y'all have seen these numbers before. Because when you're looking in the book, when you read the chapter in the book, there are examples that they gave you as they were talking about different things or different addresses, or you read other things. They use these addresses. They don't really exist on the internet, remember. Think about telephone numbers. What's the telephone exchange that they use in movies and songs that really doesn't work? 555. Basically, think of this as similar to 555. Okay? Those of you who didn't know that 555 was that way, you learned something, and those of you that did know can relate this to it. So, y'all all get something out of it either way. Okay? And once in a while, somebody will goof that up in a movie or a song and put a real exchange out there instead of using the 555, and then that drives somebody crazy because they start getting all of these people calling that number and hitting them on it. 555, y'all can pick up and dial 555s anytime you want, and you'll just get that this number doesn't exist. Okay, whether it's the exchange or the area code, the two of them don't exist. So you've got those steps there. Now, out of this, and this is where I have to look back to remember the numbers, because I don't remember all of these numbers off the top of my head. With Class A, there were 126
well, really 105, but we're going to say it's 126 networks available. Okay? With 16 million hosts of each network. So if you got given a Class A address, you could have up to 16 million hosts on your network. And they actually gave these addresses out to large companies back there in the 1980s to have them for large addresses. Companies like IBM, AT&T, etc. Microsoft was just a small little company back then, so they didn't get a Class A address. Okay? But IBM and AT&T were big ones. They issued those out, but they had up to 16 million addresses available to them. Everybody follow on that? Think about it, they really didn't need that many. But they've been given that many. When we went to running out, and they went, we're going to subdivide these and give them out differently, they went to asking all the companies to give them back. Most of them did and got given a smaller subset that was actually the size they needed, except for AT&T, and I'm pretty sure it was AT&T, did not cooperate. AT&T said, we're not going to give up our address, and they had like number 8 or something. They got a low number. They went to court and fought the U.S. government about it. Okay, and said, you gave us this address and said it was ours and gave us a permanent license for it. And the courts ruled for AT&T. They said, yep, the agreement back there when you were given it was yours and this completely belonged to you, so if you don't want to voluntarily give it up, you don't have to. They've still got their Class A address. Everybody else gave it up. Okay? And got smaller things. But you notice that one. Class B has got 65,000 host addresses. I think it's 16,000. Yep, 16,000 networks. So there were 16,000 organizations could get a Class B address. And they can handle up to 65,000 hosts on their network. Now think about it. Some of those organizations were definitely going to be bigger than 65,000. AT&T, IBM, as big as they were at that point in time, needed Class A because they were bigger than 65,000 hosts were going to be on their network. Okay? Well, they might not have been millions of addresses, but they were going to be more than that number. Well, they had to go get this huge chunk. Class C allows 254 hosts per network, which must be small organizations, and allowed for 2 million networks. But if your organization was going to be more than 254 hosts on it, you had to go to Class B. I'll follow on that. Which then gave you 65,000. And y'all see the inefficiencies we got right here. Beyond that, 127, which I left off here, is a loopback address. That's for you to be doing testing on your equipment. If you want to see, can you hit your network card, you can send a message to the loopback address of 127.something.something.something, usually .0.0.1. You may have 2 or 3 loopback addresses you test on a machine. No more than a couple of them. Usually just one. They reserved for you 16 million loopback addresses. And that people only needed 1 or 2. You see the wastage that occurred now? The inefficiency. IP version 6, 30 quadrillion addresses. Basically, from what they claim, and I don't know this for sure, because I haven't gone out and counted it myself, is they claim that will allow us to give every grain of sand in the world its own individual IP address. But I don't know how many pieces of sand there are actually out there, because I haven't tried to count them. Okay? We're not taking this class down at the local mental hospital. If I tried to count all the sand in the world, I'd probably go totally crazy, right? And if I didn't go totally crazy, he ought to be considered total crazy anyway if he's doing that. On it, when they set up the loopback address in IP version 6, it is the one address I can tell you of IP version 6. They only gave it one address. It is 31 zeros followed by a 1. Okay? I can't tell you the other IP version 6 addresses, but I can tell you that one because it is 1. And that they chose to use that one for it, and they gave us just one of them. And that's all we needed. No wastage there. Okay? So that is class those. That's your private addresses. Now, on IP version 6, you don't have to worry about public versus private addresses. Every machine gets its own unique address anyway. Now, depending on which way you're using, whether you're using Slack or you're using DHCP, to assign the addresses, it can come up with a couple of methods to assign that address to it, but you're really not giving a specific address to the machine that relates to the network. You actually play it off of the MAC addresses of most of them. Because if you look at Slack, it goes and uses the MAC address as part of the IP version 6 address, which is the additional. The other part is on IP version, so on IP version 4, it has got 4 octets, and those 4 octets, depending on if we're class A, B, or C, it splits into which portion of it is a network address, which every machine on that same network's got the same network portion, and then the host is unique. Class A, the first octet is the network address, which remember is going to be between 1 and 126. And then the other 3 octets are actually just host numbers. Now, on your private addressing that you're going to do normally on most machines now, a lot of people use the class A to do for their private, because then they can do whichever number they choose of between 1 and 126, except that they're going to use 10, obviously. And then they can say maybe that this octet tells us which building the machine's in, this one what room it's in, this is the specific machine within the room, and we can look at the address and know where it is. Or we can just assign every machine its own unique little address and have no system to it. And you see both ways out there. Okay? I like the bit of come up with a naming scheme. Then when you get a message about a machine is doing weird things from its IP address, you can look at the IP address and go, I know where that machine is, and head to find it real quickly without having to look it up in a master list, figure out where it is, and go see what's wrong with it. Because John's been sitting there playing with the IP addresses on it and has got it doing all kinds of weird things out there. And so I can walk in and catch John doing them. Or that it starts sending me messages about that whoever's using this doing inappropriate things on the website. I can go catch the person doing it because I know which machine they're at. Okay? Class B, the first 2 octets are the network address, and the last 2 is the host. Class C is the first 3, and the last one's the host. Everybody follow on that? Now, that will be expressed as, and this is going to keep it simpler now, subnetting, which it got into in chapter 8. you actually can take and borrow from the host and set network addressing on over into the host area. Okay, and split your network up into smaller parts. That gets more complicated, and read and listen to my handouts on it. I'm not going to try to get into that today because that really will. This is enough information for y'all today, okay, without touching on that. But this you will see expressed as 255.0.0.0. This one is 255.255.0.0, and this one is 255.255.0. The number standing there is a subnet mask, which tells us which portion of that address is the network portion and which portion is the host portion. That then allows the machine to look at it and know, aha, this tells me when I've got this subnet mask, when I look at the address, all I need to do is look at the first part of the octet to decide if it belongs on this network or it belongs on another network. Or if it is on the right network, then all I've got to look at is the last portion of it. Now, that is when it's on class boundary, which we really don't use it by class boundary anymore. But if you took this class from Microsoft, this is all they're going to tell you about. What Chapter 8 gets into is you can split your network smaller, and you will actually see these numbers have other numbers besides 255 and 0, which will split it on bit lines within the byte. Okay? Does everybody follow on that? And what they're saying is that this one is all, if this was class A, is that the first octet is all ones for the subnet mask, and the rest of them are a whole group of zeros. Well, we can borrow in there and put ones on over there, but it's always ones all the way to the left, and when the ones stop, it's all zeros from there on out. The 0 says it's a host portion. The binary 1 says it's a network portion. So, do see it with the 255s and zeros, but be aware it's not just 255s and zeros. When I got my CIST, which is Microsoft's highest networking certification, okay, I had to pass 7 tests to get it. And some of those tests took 2 and 3 times to pass. So probably of 7 tests that I had to pass, I probably took 16 tests at $100 and some a piece. So y'all can sit there and do a calculation real quick and figure this thing cost me over $1,000 just the test fee, not counting the fact I had to usually, most of the tests I had to drive about 80 miles to go take the test at another location from where I was in Athens, Georgia at that time. And take time off for the afternoon to do it, although at school I could do it on school time. My impression at that time was it was just 255s and zeros, because that's all they told me about. When I went to take this class from Cisco in 2001, okay, August 2001, that then when they said about subnetting and these could be other numbers, that blew my mind for a little bit, and I had to get taught how to do that. Well, Cisco then showed how to do it all, but Microsoft hadn't really gone into that much more detail to it. Does everybody follow on that? But catch the idea of it here. Now, when you go to borrow bits and everything, that gets complicated because you've got to add up parts of bytes to get the numbers and figure out where it splits on, and it can get really complicated. Maybe Tuesday when we come back, I'll try to go through and show you all on that one. So let's push the Chapter 9 test off to it. Should be due on the 3rd now. Does that sound right?
Chapter 8 test, you mean?
Huh?
Chapter 8 test? Chapter 8,
8,
that's
yeah,
what we're doing.
Chapter 8.
It's on the 10th.
Huh?
Celebrate this on the 10th.
It's not until the 10th? Good. All right, so when we come back on the 4th, okay, I will do submitting that week for you. We'll look at that and y'all look at that. Okay? So we'll break all of that down. So we'll deal with that. Okay, is everybody follow on that? And y'all are gonna need the time to listen to it, and that'll make that then occur correctly. So we'll be back on schedule correctly. So do not take the Chapter 8 test until after we're back here in school after spring break. And you listen to the lectures. Everybody got that? Don't try to do it beforehand. No matter how smart you think you are. Because you will blow your mind completely, because it was a hard one for me. And y'all, most of y'all are sitting there thinking, he's pretty smart. Well, I'm not as smart as y'all probably think I am. I am smarter than a fifth grader. At least most fifth graders, although I have known one or two that will throw them out of that equation, because them and Albert Einstein would have gotten along real great together. But I will show you some systems to do it, okay? IP version 6 gets a whole lot easier. Big thing on it that you will deal with is that the hex tests, consider them split into groups of 4, 1, and 3. Remember I said there's 8 of them, as opposed to we had 4 octets. And remember, each hextet is 4 hex characters, which really means each hextet is 2 bytes long. Okay? On here, with the way they designed it, the first 4 tells us the network in IP version 6. The next one here tells us the subnet, and then the last 3 is the host, which gives you gobs of hosts per network. You don't have to sit there and do all the splitting of numbers like we're going to do in IP version 4 to split it into subnets. All you will do is just assign it a number here in that 5th hextet. And you'll just assign the first subnet, subnet 1, the second one, 2, 3, and you've got thousands of those. Because remember, it goes all the way up to F, 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 F. If it just went up to 9s, you have 10,000 subnets available to you. Truth be, you've got tens of thousands of subnets available to you, and you're not going to have that. And you don't have to worry about all of this mess we get into in IP version 4. IP version 6 will be a whole lot easier. It's just you're looking at different numbers. They're not, the big confusing one for people is it's in hex, not in decimal. And in fact, it's got letters for numbers blows a lot of people's minds. Okay? Well, once they get that part settled, it works smoothly for them. So you don't have as much to learn about IP version 6 as 4. So we have now moving to IP version 6. 2 years ago, I think it was. Don't hold me on exact date on that, but somewhere about 2 years ago, the federal government tested all of their equipment on IP version 6 data, which occurs, I think, in May annually, if I remember right, and checked to see if all of their equipment would work on IP version 6. It does. They had been working for years to replace stuff and get everything up to that it would support IP version 6. Still supports IP version 4. Now, there's a lot of equipment out there in the world still in use that does not support IP version 4. I mean IP version 6. Which means those equipment machines are going to have to use
IP version 4 still. So most stuff being put out there now actually has a dual addressing to it. If you're using Windows XP or before, you can't do IP version 6 without doing a special installation to it to add IP version 6 to it. Because those and prior did not support 6. There is a large amount of the world still using IP version 4, using Windows XP and before. And so they're stuck on IP version 4. Give us a few more years and we will move to doing IP version 6. And that IP version 4 will gradually disappear. However, I expect you'll still see IP version 4 being supported and used for at least another 10 years, maybe 20 years, as we gradually finish phasing on out, but it will become a dominant IP version 6 world. And with your ISPs now, some of them are issuing you both an IP version 4 and an IP version 6 address. Comcast gives you both IP version 4 and IP version 6 address. Northland Cable in South Georgia only gives me an IP version 4 address. So some other smaller ISPs particularly are still issuing out just IP version 4 addresses. And so it has to be, if you want to go to a certain web page or do certain things out there, you have to use IP version 4 when connecting through with them because their stuff doesn't know 6. But that's gradually keeps on changing. And that you'll see more and more of 6. And we're gradually moving into it. And we've been gradually moving into it, but now we're jumping in even faster with the fact we've run out of addresses again. And that we've got to go to 6. All right, questions on all of that? I've given y'all a lot of information today. I've also thrown in there a number of opinions on some stuff, so there's some things I did tell you. It's my opinion. How quick are we going to be on IP version 6 completely? That's my opinion on that. Some other people are going to tell you it's going to be all IP version 6 within 2 years, but I've been told that for 6 years now. And I say I think it'll probably take a good bit more time because people don't throw out equipment as fast as people really think people could. Okay. And then you also have seen on my presentation my experiences of what we've gone through along the way and that I've been through this as we've gone. So it's not just me knowing how to do it theoretically. I have done all of this stuff in actuality. And I set up the machines onto it in the different ways. John?
Well, I mean, you wouldn't want to do this, but I often wondered, your router is doing the NAT translation, right? But what if you didn't use one of the private IP addresses? You made a mistake at home and you said, okay, instead of 192, I did 193. First of all, would the NAT still work with like a 193 number? And but what if you just like turned off NAT and used somebody else's IP address? Would that just
Okay.
would your ISP filter that, or would it just go out there and cause problems in the internet?
First part of it, you could use anything you wanted internally and let NAT switch whatever internally. So
now to look
if
at
we
any
wanted to
addresses.
use, let's say AT&T uses 8, okay? And I don't remember what number AT&T got to keep, but we'll say it was 8. You could actually use 8 inside in your network for all of your addresses, and NAT would sit there and convert the 8s to the real IP address out there and do a conversion.
So NAT just converts anything that comes
It'll
to it.
convert anything, as long as we tell it what it is, the type addresses we're going to use in our network. We tell it that, and it converts those addresses to the address we tell it is the real address out there on the internet. So it really doesn't make any difference if you use public or private addresses inside, but you should be using a private address.
Okay, and I
Should.
And I think on my router, when I go in there, it says use NAT addressing, and I can turn that on or off. So what if I
Yes.
turn that off and then use?
If you turn it off, then you set yourself back to 1996. And every machine to be able to communicate out there onto the internet from all of your machines in there have got to have an assigned real IP address. Now, if you went and chose an address that is used by somebody else, it wasn't issued to you, you are going to create a problem temporarily on the internet because it's going to suddenly see duplicate addresses coming across the internet and go, wait a minute, this is the same address as someplace else is using, and you're going to create complete confusion on your stuff and that company's stuff corresponding until the internet can, through its routers, can go block these addresses over here because they're illegitimate. Okay?
Well, it seems like with all that the routers do, and of course this would be a lot of work to set it up for each user though, that the ISP assigns you an IP address, and it seems like they could say, okay, anything coming from this line, if it's not that address, just block it.
And that's basically what they do. Okay? And that's what the ISPs normally are doing, and that they're keeping whatever address they have assigned to your network is what they've kept in their table, and if something comes across from yours going onto their network and it's not on their table, they just drop it and ignore it. And so that means I can sit there and connect into EPB's network if there was a connection going into my house, connect into it and start to try to use it, but I'm not going to get anything done because it's got to travel through their gateway to get out onto the internet. And they're going to look at it and go, that's not an address that we recognize. Actually, they're going to work off the MAC address and not the IP address to do that. And they're going to go, MAC address this is coming from is not one that is paying us our monthly payment. We're going to block this from here and prevents us from using it. Now, that also means if EPB came and installed me and set me up, they got my MAC address off my machine and put it in their table. I then go to add some more machines at my house. Either I've got to call EPB and tell them, here's some more MAC addresses I've got now, and they'll do it real quick and simple. I can't say for sure on EPB, but I can tell you on a number of other ISPs, it's real simple to do because I've done it. Call them and tell them they check to make sure you are a legitimate subscriber, and they add the numbers you gave them to them. Or you take your switch box sitting there and tell your router sitting there and tell it, instead of using the MAC address that's really on that router, use the MAC address of this PC that's on my network and look like it because that's the number that was registered with EPB. And then everything comes out of that router has that MAC address on it, and it says, oh, they're all okay even though they're coming from a dozen different machines because it just sees one MAC address on it. That router in turn goes, when it comes back into it, it goes, oh, that's not really for me with that MAC address, even though that's mine. I know that really belongs to somebody else inside. I'll switch it to their real address, which is doing the same thing we talked about with NAT, except doing it with MAC addresses instead of IP addresses. Does that make sense now?
Yeah, I've just always wondered,
And,
what if you don't use that? But I imagine.
Now, if you're doing DSL type approaches, they actually just sit there and see, should you have an active line to your house, and they're playing off the telephone line on that. But cable connections and others similar to that, they play off a MAC address and keep a MAC address table up. And that is a problem occasionally when somebody goes and buys another piece of equipment that they then go, I can't get on the internet anymore. All they got to do is call up their provider and go, I got this new piece of equipment, and they'll go, I need the MAC address from. And most people are gonna go, the what? And they'll go, look at the box, flip it over, and you should see Mac, and then a bunch of letters and numbers. Read me that number, that's those are letters and numbers after the word Mac. And then they put it in correctly into their table. And then if you don't pay your bill, all they do is just go in and disable that MAC address, and they effectively cut you off of your house, and they don't have to go do any cutting of power or anything else to you. You can still put stuff out onto their network, but it doesn't go anywhere because it says, we don't know what to do with this address, and it just ignores it and it dies. Does that answer the questions?
Yes. But you know what I never realized about phone companies? I mean, you think with the network, we're all on like a common line and it's different
Mhm.
frequencies, or if it's fiber optic, they can combine it and all that kind of stuff. But for every analog phone out there, they have
There's a separate wire running on that.
separate
That's why
wire
you got those
running
huge
to
bundles of
RTC.
wires running down, because you had a separate wire running back to the switch box.
They have
on
huge
it.
rooms with just the wires coming in.
To get to the
just
switch
huge.
boxes that
Yeah.
then combines it
I mean, you
together.
think there's some way they could like combine that and have it all come into like a computer or something and then separate it there or something. I guess IP phones are changing that though.
And that's changing the whole thing, and that's why you don't need those big bundles of wires running down the road anymore. And that they're running in fiber to the poles, and they're putting the switch box on the pole is what they're doing, because you see those little boxes in the wire that
Yeah.
look like about like that. Actually, what's inside that little metal box, and there's a switch. And then they're just dropping.
So they just
switches.
run into that box now and then do it
And it
fiber back.
combines it in, sends it on along the way. Where it used to be, they had to run a separate little wire
All the way.
all the way through all those, and they had those big panel boxes, remember, out on the street, and you'd go, how in the world, when you'd see somebody working on it, how do they keep all those little wires all straight? But that 3 million wires going into that box sitting there. As we go to the IP phone system, it makes it a whole lot easier. It's a little more complicated theory behind it, but it makes it a whole lot physically easier and everything else. All right, other questions? Hopefully y'all got a good bit out of it today. That I've helped y'all some with it, that you've got a better idea. These are the chapters that I told you were the hardest ones in the book for you. Okay? So if you're having troubles through it, don't panic over it. And remember, you've got 11 tests that you're going to have. That's 50% of your grade. So each of the tests is less than 5%. So if you bomb the test, you're still okay. All right? Because your wiring, your cabling that you've done, that's one of your lab grades. And the other part is when you come back and do it the last week, that's 10% of your grade in this class right there, just making those 3 cables the last week. Which should be 10% every one of them should get. So if there's 10 points, you should have your own grade that's been off here at the last week. Jump your grade by 10 points. I have transferred most of y'all's grades from Cisco to Blackboard and vice versa. I think in this class I didn't get them all done. I think I only got through like chapter 5. But most of them are transferred out there for you now, so you can see grades in both places. The online class, I actually got all of theirs done as of the other day, but that was like on Monday or whatever. And there's been more work done since, so obviously it's not completely up to date at any given point. Whatever point I go to do it each time, I'll be up to date right then when I stop, and then somebody will take a test or turn in an assignment, and it's not up to date any longer. But they are being transferred now. So I did have some time the other afternoon that I worked on that. If you haven't looked out there, but some of you may have looked out there and went, oh, there's actually lab grades sitting out there at Cisco now, or there's test grades sitting at Blackboard. Questions? If not,
I was going to ask about Slack. So it uses your MAC address.
Mhm.
So that mean it would be like completely impossible to get a duplicate